Hello students, in this session we will do the PYQs of the chapter Structure of Atom. We have already done the theory part which consists of 2 sessions. You should be clear with all the theory that we have seen. We have seen four different quantum numbers. They were principal quantum number, azimuthal quantum number, magnetic, and then the spin quantum number, right? Then we did see the arrangement of electrons in the atom. Got it? So the electronic configuration of different element that was seen. And then finally we saw Heisenberg uncertainty principle and then what is meant by nodes and all those stuff, right? So you should be clear with all the theory part that we have discussed. As I've already told you, I have left the first part of the chapter. We will do that stuff exhaustively in the physics second volume of the 12th. Got it? Once you are thorough with those chapter, obviously you will be able to solve all the sums from the first part of the session. Got it? From this chapter, okay? By the way, you have got around like 30 sums that we will do in this session. All the 30 sums will be done in the session itself. I have purposefully left the first part sums, got it? Because I haven't taught anything related to it, right? So theory part wasn't discussed, which will be done in the physics, class, okay? So that's what you need to know. By the way, all those first part questions that you have from this chapter, Structure of Atom, can be easily solved once you are thorough with the physics chapter that we will see in the 12th grade. Got it? So once you are thorough with those kind of sums, they will be like extremely complex. If you're okay with solving those physics 12th problems, then obviously you'll be able to solve this Structure of Atom first part questions and all those stuff. Got it? Right? You shouldn't have any doubt. Let's jump into the first question. Here you've got, if uncertainty in position and momentum are equal, then uncertainty in velocity is. So once you get the statement uncertainty, I'll have to use this Heisenberg uncertainty law, which is this formula, right? So you'll have like del x multiplied by del p, isn't it, which is greater than or equal to h divided by 4 pi. This is what you'll get, right? What they're asking is to find is the uncertainty in the velocity has to be found. So here I'll have to get the del v, isn't it? So what I'll do is I'll just convert this del x to del p because they have given us these two stuff are equal, isn't it? Momentum and then the position are equal. Therefore, obviously del x has to be equal to del p, isn't it? If that's the case, I'll just replace this del x in terms of del p. Got it? One step will get the answer. Del p the whole square, which will be greater than or equal to h divided by 4 pi. Got it? So instead of this del p, let me replace it with mass times change in velocity as usual. Yeah, so you'll have mass m square del v the whole square, which is greater than or equal to h divided by 4 pi. Yeah, that's it. You've got the answer. Del v, the del v square will be equal to h divided by 4 pi m square. Got it? Next, what I'll have to do is I'll just have to take the root, isn't it? Yeah. When the square comes to the other side of the equation, you'll have root. Yeah, that's it, finished. So you will have del v, which will be greater than or equal to 1 divided by 2m. Let me take it out of the root. So then you will have root of h divided by pi. Got it? 1 divided by 2m, root of h divided by pi. The answer here is option 3. Find simple sum, straight away sum, you'll get the answer. You shouldn't have any confusion in this question. Let's move to the next one. This question is also simple, easy one. They have given us the measurement of the electron position is associated with an uncertainty in momentum which is equal to 1 into 10 power minus 18 gram centimeter second inverse. Fine, sir. They have given you the CGS system over here. Fine, that wouldn't be any problem while solving the sum. Anyway, what they have given us is uncertainty in momentum. So they have given us del P. Fine, what they're asking us to find is the uncertainty in electron velocity is. So I'll have to get the uncertainty in the velocity of the electron. Got it? So they have given us the mass of the electron in terms of gram itself. Therefore, I'll be able to use it straight away because here also they have given the units in CGS system, centimeter, gram, and then the second. Fine. Even if you look at the option, even in the option, you have got the velocity to be in the units of centimeter second inverse. Therefore, I do not want to change the units in this situation. Just do the solving straight away, you'll get the answer. Yeah, just one step, you'll get it. Del P, change in momentum, should be equal to 1 into 10 power minus 18, isn't it? 1 into 10 power minus 18. What they're asking us to find is uncertainty in electron velocity. So if I have to plug in for the P, you will have mv, isn't it? Therefore, mass will be constant. Therefore, m times del V will give you the answer. M times del V will be equal to 1 into 10 power minus 18. Got it? I just need to get the del V, isn't it? Just do the rearrangement, we'll get the answer. Therefore, you will have 1 into 10 power minus 18 divided by 9 into 10 power minus 28 gram. That will be in the denominator. Yeah, yes. 9 into 10 power minus 28. Fine. See, if you just look at this option, everything has like 1 into it. Just the power, that is something that I need to get. Okay, therefore, I'll be able to approximate this 9 as 10. If I do approximate that one as 10, then I'll just replace this entire term by 10 power minus 27, isn't it? Yeah, that's going to be 10 power minus 27. So if I do cancel out these two stuff, you will have like 2 and then 10 power minus 9, isn't it? If it comes to the numerator, the answer over here is 10 power 9. Therefore, the answer is 1 into 10 power 9 centimeter second inverse, which will be the answer for this question, which is option 3. Right? Simple sum, straight away sum. You shouldn't have any doubt in this question. Let's move to the next one. This sum is also simple one. Let me read the question. Given the mass of electron is 9.11 into 10 power minus 31 kg. They have given us the mass of the electron. And by the way, they have given us the Planck's constant, which is the h, 6.626 into 10 power minus 34. But I do not want to worry about this Planck's constant. We'll get used to this constant more often in the physics, fine. Obviously, in the second volume of the physics in the 12th grade. The uncertainty involved in the measurement of the velocity within a distance of 0.1 Armstrong. So Armstrong actually means 10 power minus 10 meter, isn't it? You have to be clear with that convention. So that this is going to be 0.1 into 10 power minus 10 meter. Got it? What they're asking us to find is the uncertainty in the velocity, isn't it? So del V is something that I need to get. So you will have del x multiplied by del p, which should be equal to greater than or equal to h divided by 4 pi. Fine. For del x, I'll substitute 0.1 into 10 power minus 10. So that will go to the del x. Instead of del p, I'll write it as m del v, isn't it? From there, I'll be able to get the del v. Mass, that one will also go to the denominator, isn't it? So let me rearrange this equation one more extra step. So if I do rearrange this one, you'll have del v, which will be greater than or equal to h divided by 4 pi s del x into m. So this is how it's going to be. Yeah. So instead of h, let me write 6.626 into 10 power minus 34. 6.626 into 10 power minus 34. That will be the numerator. Then you would have got 4 into 3.14 instead of 5. Then for the del x, you'll have 10 power minus 11. Yeah, 0.1 into 10 power minus 10 will give you 10 power minus 11, right? So that will be 10 power minus 11 into the mass. Mass will be 9.1 into 10 power minus 31 kg. Yeah. So the next term is 9.1 into 10 power minus 31 kg. That's it. Just solve it, you'll get the answer. See, if you look at the option over here, it's obvious 5.79, 5.79. Therefore, even if you end up solving this one, you'll get 5.79. So do not want to worry about the numbers. Only thing that matters here is the powers. That's what I need to figure it out over here, right? So even if I do the approximation, that wouldn't be of any issue over here. Now, if I solve this one, you'll have 6.626. That will be in the numerator. Same way 3.14. Let me do the approximation. If I do the approximation, this will just somewhere go to 2. Yeah, that's a vague approximation that I've done over here. Then same way 9.1 times multiplied by 4, that will give you, let me approximate this one to 10. So you'll get like 40 over there. Yes, 4. Yeah, that's obviously 40. So if I do solve this one, so these two stuff, yeah, I've just cooked up that one to 40. Then if I do cancel this one, you'll have to 40, that will give you 20, isn't it? Yes, that's it, finished. So 1 by 2 is nothing but the 0.5 over there. As I've told you, Here, if you just look at the option, everything is fine, right? So I do not want to solve much more resolving the numbers. Got it? Yeah. Now just if I play with the powers, I'll get the answer. Here you have got 10 power minus 34, 31, 34. Therefore, these two stuff will get cancelled out. Yes. So that will give you, yeah, that's gonna give you 10 power minus 3. Yes. Yeah. So same way, if I just cancel these two stuff, that will give you 10 power minus 8. Yeah. So 10 power minus 8, if it just comes to the numerator, you will have no 10 power minus 8, and then you have got one more 20 into it, right? 10 into it, right? So that will give you 10 power minus 7. So that 10 power minus 7, if it comes to the numerator, you will have 10 power 7. Okay. So you have got like 0.5 into 10 power 7. So if I do the approximation, you'll have 5 into 10 power 6, isn't it? Therefore, the answer over here is 5.79 into 10 power 6. Got it? You should be clear. I've just used this Heisenberg uncertainty law straight away. Yeah, just play with the numbers, you'll get the answer. Got it? You shouldn't have any doubt on this question. Let's move on to the next one. This question is based on the Aufbau principle. They're given as 4d, 5p, 5f, and 6p orbitals are arranged in the order of decreasing energy. Got it? So there you'll have to know this order. It is in decreasing energy. Fine. The correct option is, got it? So 5f is greater than 6p, something like that. First, I'll have to know the Aufbau arrangement, isn't it? For the multi-electronic atom. Let me draw that structure or the diagram. So you would have got something like this, isn't it? 1s and then 2s, 2p, then you would have got 3s, 3p, 3d. Next, you will have 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. Then you would have got 7s, 7p. Okay, then yeah, that's it. I think that's gonna be sufficient. Yeah, that's gonna be enough. Yeah, let me draw this one. So if I draw, you will have 1s, then you would have got 2s, 2p, 3s, 3p, 4s, 3d, 5s. So this is how it's going to be. Yeah, now let me do the comparison. So this is like 6s, isn't it? I've made a mistake over there. This is 6s. 6s and then the 6p. Yeah, that's a mistake. So 6s, then you would have got 6p. So here you would have got 7s. Yeah, that's enough. Now let me verify it over here. So if I do verify this one with the first option, 5f. So you have got 5f over there. Fine. Okay. Then you have got like 6p. So 6p is obviously 5f is greater when compared to 6p. That is fine because after 6p you would have got 5f. After 7s you would have got 5f. Therefore this is right. Okay. Yeah, that logic should be clear. More it is away from the nucleus, you will have higher energy into it. Then obviously 5f will be the outermost shell when compared to that of the 6p. Therefore, this will have higher energy. Yeah, the logic should be clear. So 5f greater than 6p is right. Then 6p greater than 4d. That one is also right. Yeah, but in the case of 5p, so 5p comes after 4d, isn't it? Therefore, this one has been flipped because 5p should come first, then comes the 4d. But here it is like other way around. Therefore, option 1 isn't the answer. Got it? Let me verify for the second option. Then for the option 2, you would have got 5f. Yeah, you would have got like 5f. Then comes the 6p. That's behind the 5f, obviously. Then you have got 5p and then you have got like 4d, right? So obviously that should be my answer. Therefore option 2 is the answer over here, right? You just do the verification for the option 3 and then the option 4. Those two stuff will be incorrect. Got it? So this is how I'll have to figure out the decreasing energy. Once you are clear with this Aufbau arrangement, more farther away from the nucleus, it will have higher energy. Got it? So that's the understanding that you need to know. So more farther away, then obviously that will have like higher energy. So that will come at the last in the above arrangement of the element. Okay, right? You should be clear with this idea. You shouldn't have any doubt in this question. Let's move to the next one. Simple one, right? This question is simple one. It is based on the concept of node. Orbitals having 3 angular nodes and 3 total nodes is. So which one of the orbital over here has same number of 3 angular nodes and then the 3 total nodes? Got it? First, let me verify it for the 5p. So for the 5p, I know the total node will be n minus 1. We should be clear with this formula. N will be 5. So 5 minus 1 will give me 4. Okay. Then for the p, it the angular node will always be equal to L, isn't it? So for the p, it should be like S, P, T. Okay. So 0, 1. So L will be equal to 1 for the p. Therefore 4 and then the 1. These two are not 3. Right. Therefore, option 1 wouldn't be my answer. Then you have got 3D. The total node will be equal to n minus 1. That will give you 2. Then with the case of D, S, P, D. Yeah. So D over here is actually 2. Therefore, 2, 2, both are same. But what they're asking us to find is 3 angular nodes and the 3 total nodes. Therefore, option 2 will also not be my answer. Then for the 4F, if I verify it, 4 minus 1, that will give me 3. Same way for the F, 0, 1, 2, 3. Yeah, that verifies 3, 3. Both are same. Got it? Therefore, 4F should be my answer. Got it? 4F will be my answer. You shouldn't have any doubt in this question. Simple one. Let's move to the next one. This question is statement based sum. Let me read the question. Which one is a wrong statement? I'll have to just get the wrong statement from the options that they've given over here. The first option is total orbital angular momentum of electron in s orbital is equal to 0. Got it? So they have given us the orbital angular momentum of electron in s to be 0. Let me get the formula for orbital angular momentum. That will be root of L into L plus 1, isn't it? Into h divided by 2 pi. If it was only angular momentum, then you wouldn't have this 2 pi. Here they have given you like orbital angular momentum, therefore you would have got this 2 pi. Anyway, it doesn't matter for this sum. So here if you just look at this formula, you will have root of L into L plus 1, isn't it? For the L, you would have got 0 because it is s orbital. Therefore, this term goes to 0. If this term goes to 0, the entire term is 0, right? So, option 1 is correct. What they're asking us to find is the wrong statement. Therefore, that wouldn't be my answer. Fine. Then, for the option 2, they have given us an orbital is designated by 3 quantum numbers, while an electron in an orbit in an atom is designated by 4 quantum numbers. Yeah, that's right. Because if you have to get the particular orbital, I just need to know the principal, magnetic, and then the azimuthal quantum number, right? So the first number, that will be the principal quantum number. Then you would have got S, P, D, F. That will give you the azimuthal quantum number. Same way for the magnetic quantum number, I'll be able to get the box. That's going to be the orbital, isn't it? Shell, subshell, then you'll get the orbital, right? Then if I need to get the electron, I just need to know the final quantum number, which will be the spin quantum number. That will give me the direction of the spin, plus half or negative half. Therefore, option 2 is also correct. What they're asking us to find is the wrong statement. Therefore, that is not my answer, right? Then if you look at the third option, the electronic configuration of n atom is. So here, yeah, if you just look at the electronic configuration, I know nitrogen has like 7 electrons into it. So obviously 1, 2, 3, 4, 5, 6, 7. Yeah, these two will be completely filled. In the case of 2px, 2py, and then the 2pz, everything has to be singly occupied, then pairing has to begin. So when it is occupied singly, everything has to have the same orientation or direction into it, direction of spin into it, right? But if you look at over here, two things are upward while the third one is like downward, right? So this is Hund's rule. So pairing will begin only after all the electrons are singly occupied. Got it? But here, even though it is singly occupied, one of the direction is opposite to that of the rest two direction. Therefore, that will be my answer, right? So the answer over here is option 3. Fine. I'll just verify the fourth one also. That is something new. That's fine. So here for the fourth option, they have given you the value of m. M is the magnetic quantum number of for d z square is 0. Okay. So they have given you the value m for the d z square, which is going to be 0. I haven't told you anything regarding to this one in the theory part. I'll just tell you now. So here you have got for the p, you would have got like orbital something like that, something like this, px, py, and then the pz. So generally in the chemistry, z axis will be my prime axis. I'll give 0 to that one. Fine. So 0 will be given to the z, and then for the x and then the y, you would have got +1 and then the -1. Got it? So this is how it's going to be. So whenever you get the prime axis, that will be the 0, designated as 0. So for here, you have got like dz square, isn't it? So if it was like dz square, let me write it this fashion. You would have got dxy and then dyz and then dxz. Okay, then you would have got dx square minus y square. Finally you would have got dz square. Okay, if I just have to number this one, yeah, obviously I've told you this will be like 0 because z will be my prime axis, therefore that has to be 0. They have given us clearly the value of m for dz square is 0. Yeah, that is obvious. So that option is also correct. Okay, then for the rest all other numbers, let me give it in this fashion, +1 and then the -1. For this one it's like x, y, isn't it? So +2 x square minus y square, let me give it like -2, right? So do not want to worry about this numbers. Yeah, that will flip depending on the orientation that you're going to take the atom. But with the case of z axis, that's the prime axis about which I'm going to learn. Therefore that will always be designated 0, right? So here the value of m for dz square is 0. That's right. Got it? You shouldn't have any doubt on this question. It has to be clear. Yeah, this is a statement based sum. Let's move on to the next one. Next question is, which one is the wrong statement? I need to get the wrong statement from the option over here. First, they're given us the uncertainty principle is del E multiplied by del T greater than or equal to h divided by 4 pi. Got it? So here they've given you the work instead of del x del p relation. So just let me plug in, instead of del E, let me just plug in force times the displacement and let me solve it, right? If you're thorough in the physics, if you're clear in the physics, you should know this rearrangement. As if now, if you haven't learned work, energy and power from the physics, then this will be a kind of new formula, right? Anyway, once you learn the chapter in the physics, you'll get it straight away. That's the fourth chapter in the physics. Fine. The formula for the work done will be force times displacement. Yeah. Instead of force, yeah, del W will be equal to del E in this situation. Therefore, instead of force, I'll just replace it with change in momentum divided by the time interval. That will give you del P divided by del T. Yes, multiplied by del X. Got it? So, if I just substitute del P divided by del T into del X into this one, then obviously I should get del P times del X. Let me check it. Instead of del E, let me substitute del P divided by del T into del X multiplied by del T, which is greater than or equal to h divided by 4 pi. Yeah, when you look at this equation, it is obvious. Del T will get cancelled out. Then you will just be left with del P multiplied by del X, which will be greater than or equal to h divided by 4 pi. Therefore, this is obviously Heisenberg uncertainty principle. Therefore, the option 1 is correct, which means it isn't my answer because they're asking us to find the wrong statement. So first option is correct, which is not my answer. Then half-filled and fully filled orbitals have greater stability due to greater exchange energy, greater symmetry, and more balanced arrangement. Yeah, that's the correct argument, isn't it? For the half-filled, you'll have greater exchange energy as it will be able to jump between the orbitals. Yeah, same logic, that should be clear. Then for the option 3, the energy of 2s orbital is less than the energy of 2p orbital in case of hydrogen-like atom. Yeah, with the case of hydrogen-like atom, it is monoelectronic atom. Therefore, 2s and 2p, those two energy level will be the same. Yeah, for the monoelectronic atom, 1s will be the lowest energy level. Then 2s and 2p, both those stuff will be equal. But here they have given you this is less. This is a kind of Auber principle which will work out for the multi-electronic atom. But with the case of monoelectronic atom, that shouldn't be the consideration. Therefore, option 3 is actually a wrong statement, which is something that I need to find. Therefore, option 3 is the answer over here. Option 3 is the answer, right? Then you have got de Broglie wavelength is given by lambda, that will be equal to h divided by mv, where m is the mass of the particle, v velocity of the particle, right? I haven't discussed anything related to the de Broglie wavelength. Fine, do not want to worry about this extra formula. You will learn this one exhaustively, thoroughly, clearly in the physics 12th grade, right? Got it? Anyway, you should get the answer by this time. The answer is option 3 because that is for the monoelectronic atom. With the case of monoelectronic atom, 2s will be equal to 2p, right? You should be clear with this question. No doubt should be there. Let's move to the next one. Next question is simple logic based one. They have given us how many electrons can fit in the orbital for which n is equal to 3, L is equal to 1. Okay, so here it's just the straightaway one. How many electrons can fit into an orbital? So how many electrons is possible? Two electrons are possible to fit into an orbital because one will be positive spin and the other one will have negative spin. That's how it's going to be, isn't it? An orbital can accommodate two electrons. Got it? Therefore, the answer here is option 2. Right? So do not want to worry about this n equals 3 and then the L equals 1. It doesn't matter over here because n equals 3 will give you 3 and then L equals 1 will give you P. So this is like 3p subshell. So in the p subshell you will have like 3 orbitals, but they're not asking us to find the number of electrons that can fit into this subshell. What they're asking us to find is number of electrons that can fit into this orbital. Whatever the orbital it is, an orbital can accommodate 2 electrons into it, right? Therefore the answer here is option 1. It should be clear. Let's move to the next one. This question is also simple perception based question. They have given you which of the following pairs of d orbitals will have electron density along the axis. Okay, so along the axis you need to have the electron density. Fine. If you are just thorough with the diagram that I've given you in the theory part, you'll get it this one straight away. So if you just look at this d, xy and the xz, all those things, that will be along those planes. It will not be along those axes, isn't it? Yeah, only the z square, dz square will be along this z axis. Same way with the case of dx square minus y square, it will be along this x and then the y square axis, isn't it? X and then the y axis, right? So this one, dz square and dx square minus y square will be along those axes. Okay, so dx square minus y square will be along the x and then the y axis. With the case of z square, that will be along the z axis and the other one will be donut shaped, isn't it? Therefore it should be obvious, option 3 will be my answer over here. Yeah, so dz square comma dx square minus y square, that will be my answer. Fine, it should be clear. Let's move to the next one. This question is simple one, straightforward one. Two electrons occupying the same orbitals are distinguished by. Fine, so you have got the last quantum number, that is what I need to get. So the last quantum number will be spin quantum number that will differentiate between two electrons which is occupying the same orbital, right? Simple one, theory based question. Option 2 is my answer. Spin quantum number will be my answer. Got it? Let's move to the next one. This question is also simple one. This is based on the Aufbau principle, which is the correct order of increasing energy of the listed orbitals in the atom of titanium. What are they have given as the atomic number, which is 22. So we have discussed this one already in the theory part. So for the element between 21 to 30, right, where you'll have like d orbitals into it. Got it? So how should it actually arrange for this titanium element? Fine. So it will be like 1s2, 1s, 2s, 2p. Then you would have got 3s, 3p, 4s, 3d. That's how the arrangement has to be there. I'll have to get such an arrangement over here also. By the way, it is based on the increasing energy. Therefore, something that is towards the right will have the higher energy into it, right? So here if you just look at this one, 4s 3s, it doesn't make sense. That makes sense. Therefore option 1 wouldn't be my answer. Then 3s 3p 3d 4s, that's not possible. Only after 4s will get the 3d, right? So that's how Aufbau principle will be there. Then for the option 3, 3s 3p, then you have got 4s, then finally you have got like 3d. This is obviously in the increasing order of energy. Got it? Therefore option 3 is the answer, right? Simple one. It should be clear. Let's move to the next one. Next question is the number of d electrons in Fe2 plus, where Z equals 26, they have given you the atomic number, is not equal to the number of electrons in which one of the following, right? So here first I'll have to get the electronic configuration for Fe2 plus. Fine. So this might be new, but you'll get used to this one as we progress in learning chemistry. Fine. So here you have got like Fe2 plus, which has like atomic number to be 26. Got it? So obviously the last 10 electrons will be filled in the D subshell, isn't it? Therefore, you would have got something like this 4s and then the 3d. Got it? 1, 2, 3, 4. So you would have got like 5 orbitals into it. So this is 3d. We know these two stuff will be filled, isn't it? And then finally, rest 6 electrons will be filled in the d orbital. Therefore, you'll have 1, 2, 3, 4, 5, and then you have got like 6. So you have got 6 electrons that got filled in the 3d subshell. Yes, if it was Fe, then this will be the electronic configuration. Here they have given us Fe2 plus, which means 2 electrons has to be removed from this set. Whenever you have got like 4s and then the 3d subshell, generally the first 2 electrons, the 2 electrons that will be removed will be from this s orbital. Okay, so that's how it will be. Therefore these 2 electrons will be removed. Same thing with the case of scandium, titanium, copper, zinc, whatever it is. Here this shows multivalency. You might have learned in your lower grades Fe2 plus and then the Fe3 plus. Got it? Ferrous, ferric. Here it is Fer-S. So in the case of Ferrous, 2 electrons should be removed, which will be from the s orbital. If it was like ferric, Fe3 plus, then one more extra electrons will be removed from this 3d orbital. Got it? But in this situation, as I've told you, this set of electrons will be removed. Okay, 4s. So this will be my electronic configuration for the d electrons in Fe2 plus, which means you will have all the 6 electrons in the subshell. Got it? Yeah, now I just need to match it with which one is equal in which one of the following. Okay, is not equal to. So I just need to get which doesn't match. Okay, let me read the first option. So you have got d electrons in Fe z equals 26. Yeah, obviously in Fe these 2 electrons will be filled, but still this you'll have the same amount of d electrons. Therefore option 1 is correct, which is not the answer. Then with the case of neon, they have given you like 10 electrons. Okay, so I'll have to match it with the p. Fine. So with the case of neon, it's like 10. So you'll have like 1s2, 2s2, and then 2p6. That will give you 10 electrons together. So in the p subshell, you have got like 6 electrons. Therefore, even in the case of neon, it got matched, right? Then let me verify it for the magnesium. So they have given you like for magnesium, you have got Z equals 12. Let me write the electronic configuration for the magnesium. I'll have to consider the s electrons. Okay, so you would have got 1s2, then 2s2, 4 electrons, 2p6, and then 3s2, right? So if you count the number of s electrons, you would have got 2 plus 2 plus 2, which will again give you 6. Therefore s electrons in magnesium will match with d electrons in Fe2 plus. Yeah, that too is correct, which is not the answer. Therefore option 4 should be my answer. Let me verify it. If I have to verify for chlorine, you will have chlorine, which will give me 1s2. Okay, then you would have got 2s2, 2p6, together it gives you 10. Then 3s2, that will be 12. So 12 plus 5 will be 17. Therefore, the next one will be 3p5, isn't it? Yeah, it should be clear. So here you have got 2p6 and then the 3p5, isn't it? So you have got like 6 electrons in the p subshell, and same way 5. So 6 plus 5 will give you 11 electrons into it. Fine, so this is obvious. Here you have got 11 electrons in the p subshell, but in the case of Fe2 plus with respect to d electrons, I just got only 6, right? So it doesn't match. Okay, I've already marked it, which is p electrons in chlorine will not match with the d electron in Fe2 plus. Got it? You shouldn't have any doubt in this question. It should be clear. Let's move on to the next one. This question is also simple formula based one. You have got the angular momentum of electron in d orbital is equal to. Got it? I just need to get the angular momentum. The formula for the angular momentum will be root of L into L plus 1 multiplied by h. If it was orbital angular momentum, then you would have got h divided by 2 pi into it. But this is just the angular momentum. Therefore, straight away, just plug in the values, you'll get the answer. For the d orbital, you would have got SPD, isn't it? 2. So 2 into 2 plus 1 multiplied by h. Okay, so that will give you root 6h, isn't it? Yeah, root 6h will be my answer. The answer here is option 3. It should be clear. You shouldn't have any doubt with this question. Let's move to the next one. This question is also a simple one. What they have given is, what is the maximum number of orbitals that can be identified with the following quantum numbers? Got it? Here you have to be careful. They are asking us to find the maximum number of orbitals. Got it? They have given us 3 quantum numbers. Fine. So when you have 3 quantum numbers, obviously that will go to 1 orbital. Anyway, here principal quantum number is 3. Then for L, it's like 1, which will give you is a P, and then M equals 0, right? So that will give you the final orbital, which will be 3pz, because generally I've told you if it is equal to 0, then that's the principal axis or the main axis. That will always be z axis with the case of chemistry, right? Yeah, so here 3pz. So 3pz designates one orbital, therefore the maximum number of orbitals possible over here is 1. That's it, finished. The answer here is option 1, right? It should be clear. Let's move to the next one. This question is also same like that of the previous one. Here they have given you what is the maximum number of electrons that can be associated with the following set of quantum numbers. Got it? Same way here you have got like 3 quantum numbers. Here what they're asking is to find is the electron. So obviously if you have got like 3 quantum numbers, then it will just get you to the orbital. In an orbital, 2 electrons are possible to be found out, isn't it? Therefore here the answer should be option 2. Anyway, if I have to get that orbital, it should be 3. Yeah. Then for L equals 1, that should be P. Then M equals minus 1 will give you either X or Y, depending. So it could be 3px or 3py. Is it is not possible, right? It should be clear. Let's move to the next one. This question is based on electronic configuration. Actually, you should have got this question in the chapter of F block elements. They have given you in this chapter anyway. So because it is based on the electronic configuration, here they have given us the outer electronic configuration of gadolinium. Got it? So they have given you new element which is gadolinium. This is F block element. Okay, from the lanthanide series. We will learn those stuff in the upcoming chapter. As if now you have got a new element which is gadolinium, whose atomic number is 64. What I need to get is the outer electronic configuration. So to get the outer electronic configuration, first I just need to know the Aufbau principle, isn't it? Yeah, to get that one, in this arrangement, if you just figure out that Aufbau principle, Aufbau arrangement, then you will have, first you'll get 6s, that will be full first. Then after the 6s, you will have 4f. After this 4f, you will get 5d. This is how you will have arrangement of electrons. Yeah, when you look at the option, they have given us the last 10 electrons over here. Just look at it. 5, 4, 1. It gives you 10. 7, 1, 2. If you sum it, it will be 10. 3, 5, 2. That will give you 10. Same way, how should I actually put this last 10 electrons? That's what they're asking us to get over here, right? So obviously, 6s has to get completely filled. Then comes the 4f. Right? Same logic that we have seen for this element 21 to 30, right? So 6s has to be filled. That will give you 2. Then after this 2, I can either put 8 over here, or else I'll be able to put 7, 1 or 8, 0 or 7, 1. That is possible. Here I'll just substitute 7 over here and then 1, because when you look at this F subshell, in F subshell you have got 7 orbitals into it. Therefore, 7 will be half filled. So half filled will be more stable when compared to other arrangement, right? Therefore, as it is half filled, this will be preferred. So 4f7, after 4f7, 5d1 will be filled, right? Then after this one, gadolinium, the next element, you'll have, instead of 4f8, you'll get like 4f9. That's how it will fill, right? So here 4f7, 5d1 will be preferred because 4f7 is half filled. With the case of F, you have got 7 orbitals, therefore 7 electrons will be half filled, right? So that's the intuition that you need to know. So if you just look at the option over here, 4f5, that's not possible. 4f7, 5d1, 6s2, that's possible. So rest stuff isn't possible. Okay, so 5d5, that's not possible, because only after the complete filling of f orbital, F subshell, D subshell will start filling. But in this situation, you have got like one electron to the D subshell because here this is half filled, which will be preferred because of the symmetry, right? The logic and idea should be clear. Therefore, the answer over here is option 2. Got it? See, this is actually a simple question, but this question is not entirely based on this chapter. Fine. While doing F block elements, you'll just do this one again and again. You'll get used to it, right? This kind of logic and those stuff. Got it? You shouldn't have any doubt on this question. Let's move to the next one. This question is also simple one. You have got maximum number of electrons in a subshell with L equals 3 and N equals 4. Fine. So I just need to get the maximum number of electrons in the subshell. So here if I just have to get this one, so N is actually 4, right? L is 3. 3 means 0, 1, 2, 3, which will give you S, P, D, F, right? So 4F. So how many number of electrons is possible to fill in this 4F subshell? It is F, therefore you'll have 7 orbitals into it. If you have got 7 orbitals, then 7 into 2 will give you 14 electrons. Got it? Therefore 14, it is possible to fill 14 electrons into it. Therefore for the 17th one, the answer is option 1. Got it? It should be clear. Let's move to the next one. This question is also based on electron configuration. The question is the correct set of 4 quantum numbers for the valence electrons of rubidium atom is. I need to get the correct set of 4 quantum numbers for the final valence electron. Okay, so if I have to get that one, first I'll have to get the electronic configuration, isn't it? So here Z will be equal to 37. Got it? So if I have to fill the electronic configuration, you'll get 1s2, 2s2, 2p6, got it? 3s2, yeah. Then you would have got 3p6, yes, then 4s2, 3d10. This should give you 30 electrons. Let me count it. It's 10, yeah, 10, 10, 30 electrons is done. Now I'll have to put the last 7 electrons. Got it? So to put the last 7 electrons, if you know that off-bow arrangement, next you'll get, after 3d10 you would have got 4p6, yeah, 4p6 and then 5s1, yeah, 6 and then the 1, 5s1. Got it? So 4p6, 5s1. So for this one, if you have to choose the option, let me verify it over here. For the 5, that's the principal quantum number, which should be equal to 5. So 3 options are possible. With the case of azimuthal quantum number L, that should be equal to 0. So 5, 0, that's possible. Then, yeah, only one orbital is possible, therefore the next one also has to be 0. So the last one has to be 5, 0, 0. It could be plus half or minus half. They didn't confuse anything with respect to the sign, therefore only one is possible, which is 5, 0, 0 plus half, which is option 3, right? Simple one, straight away easy sum. You shouldn't have any doubt on this question. Let's move to the next one. This question is also based on the formula of orbital angular momentum. Here they have given you the orbital angular momentum of p electron is given as. Got it? So I have to get the orbital angular momentum of the p electron. Yeah, the formula which I generally use, which is root of L into L plus 1. Here they have given you orbital. Therefore, you should have divided by 2 pi into it. Okay. So it's like 1 into 1 plus 1. That will give you 2. Yeah. Root 2 into h divided by 2 pi. That will give you h divided by root 2 pi. The answer is option 1. Simple, straight away, easy one. You shouldn't have any doubt in this question. Let's move to the next one. This question is also a simple one. Here you have got the total number of atomic orbitals in 4th energy level of an atom is. I just need to get the number of atomic orbitals in n equals 4. Energy level, shell, all are same, which gives you the principal quantum number. Okay, so here they have given you n equals 4. Got it? To get the number of electrons, I know the formula which I've learned in the theory, which will be 2n square, isn't it? To get the number of electrons, I can substitute n equals 4. 4 times 4 will give you 16. 16 into 2 will give you 32. But here what they're asking is to find is number of atomic orbitals. Okay, so if it has to be atomic orbitals, then obviously I'll have to divide it by 2 because each orbital can have 2 electrons. Got it? So to get the number of orbitals, what I could do is I can divide this formula by 2, which will give me n square, right? So n square will give you the number of atomic orbitals. That's gonna be 4 into 4, which will give you 16, right? The answer here is option 2. Fine. It should be clear. Let's move to the next one. This sum is also simple one. Here you've got maximum number of electrons in a subshell of an atom is determined by the following. So to get the number of orbitals on a subshell, what we do is we use magnetic quantum number, right? That one, m equals to L plus 1. That formula will give you number of orbitals possible in a subshell. Got it? You have learned it in the theory. Here, I just need to get the number of electrons. So to get the number of electrons, just multiply it by 2, you'll get the answer. That's it. So to get the number of orbitals, I use this formula 2L plus 1. For the S, it will be 0. That will give you 1 orbital. With the case of P, this will be 1. So that will give you 3 orbitals. So proportionally, electrons will also increase double the times. Therefore, for the number of electrons count over here, I'll just have to multiply it with 2. That's it. So E will have 4L plus 2. That will give me the answer for the number of electrons. That will be option 4 for this question. It should be clear. Let's move to the next one. This question is also a simple one based on quantum numbers. Here you've got which of the following is not permissible arrangement of electrons in an atom. Got it? So which combination is not possible? That's what I need to get. Got it? So if n equals 5, is this possible? L equals 3, that's possible, right? Because SPDF, right? So this starts with the whole number and this one will be from the natural number. For 1, 0 is possible, which is like S. If one number less than that is possible, isn't it? So if n was equal to 5, L equals 3 is possible. Same way m equals 0, that too is possible. S equals plus half, that one is also possible. So the first combination is possible. Yeah, let us verify it for the second option. So you have got n equals 3. So yeah, fine. So 3 with 3, this is L equals 2, which means 3D. That is possible, right? M equals minus 3. With the case of D, I know the maximum is like 10 electrons that I can fill, right? But here M equals minus 3, whether it is possible or not, that's what I need to get. So I know here for the number of orbitals that is possible, the formula that I generally use is 2 into 2 plus 1, isn't it? So that will give me 5. Yeah, so if it was like 5, 1, 2, 3, 4, 5, yeah, the 1 will be 0. Here, with the case of magnetic quantum number, I'll use the integer, isn't it? 0, plus 1, plus 2. Same way, negative 1, negative 2. Negative 3 is not possible, right? So therefore, it is pretty obvious. Option 2 is not possible, right? So that combination is not possible. So option 2 should be my answer. Let me check with the rest two other option. Obviously, that will be possible because they have asked us to find the not permissible, which is impermissible one. I just found out that one. If n was equal to 3, L equals 2, that is possible. M equals negative 2, obviously that is possible. Negative half, that too is possible. If n was equal to 4, L equals 0, possible. M equals 0, that too is possible, right? So you should be clear with this one, right? Simple one. Which one is not possible? That's what I need to get based on the quantum numbers that they have given. Got it? Let's move to the next one. This sum is also same as that of the previous sum that we have seen. Here you have got, consider the following set of quantum numbers. They have given you some sets of quantum numbers. What they're asking is which of the following sets of quantum number is not possible? Same like that of the previous sum, but you have to find it for the 5 different sets. That's it. Yeah. So here also I'll have to get which is not possible. Let me verify it over here. N equals 3, L equals 0, M equals 0 plus half, that is possible. So tick. Then for N equals 2, L equals 2, that's not possible because it has to be 1, 0, 1. Therefore, here this one is not possible. With the case of option 3, 4, yeah, one number less than that 3, which is possible. So that will be F, right? So F subshell is possible. For F subshell, obviously negative 2 is possible, minus half is also possible. Then 1 equals n equals 1, 0 is possible. Yeah. Then negative 1. See, if it is like n equals 1, it's like the first one, isn't it? So negative 1 is not possible, right? So this one is not possible. For 3, for n equals 3, 2. That is possible. Yeah, isn't it? Yeah, two is possible. So S D Shepshell is possible. For the D Shepshell, plus 3 isn't possible, right? So this one is also not possible. So here, if you just look over here, which one is not possible? That's what I need to get. 2, 4, and 5 are not possible. 2, 4, and 5. Option 2 is my answer, right? Simple sum. It should be clear. Let's move on to the next one. This one is also statement based one. Let me read the question. The orientation of an atomic orbital is governed by, right? If you are thorough in the theory, you will know it straight away. Orientation and number of orbitals is governed by the magnetic quantum number, right? It should be clear, simple sum, right? Option 4 is the answer. Let's move on to the next one. This question is also a simple one, which we have already seen. Same pattern sum. The following quantum numbers are possible for how many orbitals? So they have given you like 3 quantum numbers up to magnetic quantum number. Therefore, that will designate the orbital, right? So here also they are asking us to find how many orbitals, right? Therefore, 1 should be my answer. 1 matches with the option 1. Therefore, option 1 is the answer over here. Got it? Simple one, right? Let's move to the next one. This question is also statement based one, simple one. Here they have given us identify the incorrect statements from the following. I just need to get the incorrect statement. Here the first statement is the shapes of dxy, dyz and dzx orbitals are similar to each other, correct? And dx square minus y square and dz square are similar to each other. That's not true because dx square minus y square is still double dumbbell, but in the case of dz square it is dumbbell and then the donut, right? So those two stuffs are not same. Obviously that should be my answer because they are asking us to find the incorrect statement, isn't it? So option 1 is the answer. Let me read rest all other options. All the 5D orbitals are different in size when compared to the respective 4D orbitals. Yeah, that is correct because 5D orbitals are bigger when compared to this 4D because it encloses the 4D orbitals. Yeah, the logic should be clear. All the 4D orbitals have shapes similar to that of the 3D orbitals. Yeah, that does make sense. Both of them are double dumbbell shaped. Yeah, okay. It has to be clear. Then in an atom, all the 3D orbitals are equal in energy in free state. Yeah, when it is in the free state, which means those degenerate orbitals will have same energy into it, right? So that statement is also correct. Fine, simple logic one. Let's move to the next one. Next question is also simple statement based one. Let me read the question. Select the correct statement from the following. The first statement is atoms of all elements are composed of 2 fundamental particles. No, it is composed of 3 protons, neutrons, and electrons. First one is wrong. Yeah. The next statement B is the mass of the electron is 9.1 into 10 power minus 31 kg. That's correct. You'll get this one. Fine. As we progress in learning chemistry and physics, this number you'll by heart it. Do not want to worry about that one. All the isotopes of given element show same chemical properties. Yeah, it shows the same chemical properties because with the case of isotope, you will have same number of protons, but the neutrons is the thing that's going to differ. When you have same protons into it, chemical reaction will be same. Hydrogen, even if it has like one neutron or two neutron, it doesn't, no neutron or one neutron, it doesn't matter. Whatever the case it is, hydrogen is still a hydrogen because the element is determined by the number of protons. Fine. So all the isotopes of an element show same chemical properties. Yeah, that is correct. Protons and electrons are collectively known as nucleons. No, that's wrong. Then Dalton's atomic theory regarded the atom as an ultimate particle of matter. Yes, atom is the entity from which the rest all other matter is formed, right? Therefore, Dalton's atomic theory regarded the atom as an ultimate particle of matter. That is correct. Statement E is also correct. So B, C, and E are the correct options. B, C, and E are only the choose the correct option, right? So B, C, and E only. Option 1 is the answer. Yeah, simple one. Do not you shouldn't have any doubt on this question. It has to be clear. Let's move on to the next one. Now we are into the last question of this session, even for this chapter. Let me read the question. The relation between Nm equals the number of permissible values of magnetic quantum number Nm or M, right? So generally I designate this one as M in the theory. For a given values of azimuthal quantum number, so how should I actually get the relation? So I know Nm will be equal to 2L plus 1, right? Got it? Here, I just need to get this combination Nm 2L plus 1. This is not possible. This is also not possible. So I'll have to rearrange this one based on azimuthal quantum number. So if I do the rearrangement, L will be equal to Nm, number of permissible orbitals, isn't it? Permissible values of magnetic quantum numbers or the orbitals, Nm minus 1 divided by 2. So L equals Nm minus 1 divided by 2 will be my answer, which is option 2. Fine. Got it? You should be clear with all the sums that we have seen. You might have seen all the questions will be like super easy from this chapter. Fine. So we have done around like 28 questions, completing all the question between the years 2000 to 2023, right? You have to be clear with all the sums that we have discussed. Got it? Purposefully, I've left the first part of this chapter. Those sums will be super easy once you're thorough in the physics. Okay. The second volume of the 12th grade. If you're thorough in that physics part, these sums will automatically be easy, right? So simple solving, you'll get the answer. Fine. So this is what you need to know regarding this chapter. You should be clear with all the theory that I have discussed. Same way, you should know all the pattern sums that I have solved in this session. Got it? With this, the video gets completed. Bye.